Bismillahirrahmanirrahim. Assalamu alaikum. I am Dr. Fazullah and you are watching Easy Mathematics. These are the topics which we shall learn in this video. So let us start from the first one. Row operations or column operations in a matrix. In a matrix, we can perform three types of operations, which are called row operations or column operations. Let us see the first operation. Interchange of any two rows or columns in a matrix. So the first operation is that we can interchange any two rows or any two columns in a matrix. Rij denotes the interchanging of ith and jth row. So this is the notation. Let me write R12. So R12 mean interchanging of first and second row. The second operation is multiplication of a row or column with a non-zero number. The non-zero number may be a real number or a complex number. So in a matrix, we can multiply each element of one row with a non-zero number, or each element of one column with a non-zero number. The notation which is used for this operation is KRI. KRI denotes the multiplication of constant K with ith row of a matrix. Let me write 5 or 1, which means multiplication of 5 with each element of row 1. The third operation is addition of a scalar multiple of one row or column with another row or column, which means that we can multiply each element of one row with a non-zero constant, and then we can add that multiple to another row. The notation Ri plus Krj means the addition of k times of jth row with ith row. Let me write a simple form R1 plus 3 R2, which means multiplication of each element of R2 with 3 and adding that thing with R1. Leading entry or pivot. The first non-zero number or element in a row of a matrix is called a leading entry or pivot. Let us see some examples. So the first example, we have a matrix A, which is given by 2, 3, 7, 0, 4, 3, 0, 0, 3. Now we can see that the first non-zero number in row 1 is 2, and that 2 is called a leading entry of row 1. In the second row, the first non-zero number is 4, and that 4 is called a leading entry or pivot. In the third row, the first non-zero element is 3, and 3 is called leading entry of row 3 of matrix A. Let us see another example. In this example B, let us write 0, 3, 4, 7, 0, 0, 1, 6, 0, 0, 1, 3. In this matrix, we can see that in row 1 the first non-zero entry is 3 and that is the leading entry. In the second row, the first non-zero entry is 1 and that is the leading entry. In the third row, the non-zero number, the first non-zero number is 1 and that is the pivot or leading entry. Echelon form of a matrix. We say that a matrix is in the echelon form if it satisfies three conditions. The first condition is the first non-zero element in each row must be 1. Number 2, the number of zeros to the right hand side of 1 increase row by row from up to down. And number 3, if there is a non-zero row, that must be at the bottom of the matrix. Let us see some example. So in this example, we take a matrix A in which we have 1, 3, 4, 0, 1, 7, 0, 0, 1. Now we can see that the first non-zero element in each row is 1. First condition is satisfied. Number of zeros to the left hand side of 1 increase row by row from up to down. In the first row to the left hand side of 1 there is no 0. In the second row to the left hand side of 1 there is 1 0. In the third row at the left hand side of 1 there are 2 zeros. So number of zeros to the left hand side of 1 increase row by row from up to down. Let us see another example. In this example we have a matrix B and let us write its elements 0, 1, 4, 5, 6, 0, 0, 1, 3, 4, 0, 0, 0, 1, 7, 0, 0, 0, 0, 0. We can see that each first non-zero element is 1. In each row, the first non-zero element is 1. And number of zeros to the left hand side of 1 increase row by row. In the first row, we have 1 0. In the second row, we have 2 zeros. In the third row, we have 3 zeros. So number of zeros to the left hand side of 1 increase row by row from up to down. And there is only 1 0 row and that row is in the bottom of matrix B. So matrix B is in echelon form. A reduced echelon form. We will say that a matrix is in the reduced echelon form if in addition to these three properties of the echelon form, it satisfies the fourth property, which is the column in which one lies, all other entries of that column must be zero. Let us see example A. So in example A, I will write 1, so all other entries in the column in which one lies must be 0. Now in the second row there is 1, so all other entries of that column must be 1. In the third row there is 1, so all other entries in that column must be 1. So that's why A is now in the reduced echelon form. Or we can say that A is in the echelon form because the first non-zero entry in each row is 1, number of zeros to the left hand side of one increase row by row from up to down. And the third one, the last one, is that the column in which one lies, all other elements of that column are zeros. So this is in the reduced echelon form. Let us see another example B. In this example, we have 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0. Now you can see this matrix is in the echelon form, and in addition, the column in which one lies, all other entries of that column are zeros. So this is in the reduced echelon form. In some cases, we say that this is a row echelon form and row reduced echelon form. Row equivalent matrices. Two matrices are said to be row equivalent if one can be obtained from the other by finite number of row operations. If a matrix A is row equivalent to another matrix B, symbolically we shall write A is row equivalent to B, as you can see on the screen. Rank of a matrix. Let us see a simple definition. If we are given a matrix A, we should reduce that matrix to echelon form, and then we shall count the number of non-zero rows. So rank of A is equal to number of non-zero rows in the echelon form of a matrix. In this example, we should learn how to reduce a matrix to echelon form and to reduced echelon form, and how to obtain the rank of a matrix. So let us start the solution of part 1. So we can write that A is row equivalent to another matrix, which is obtained by the row operation. The first thing which we need is that guy should be equal to 1. So we can divide row 1 by 6, or we can interchange row 1 and row 3. So by the operation R1, 3, which means interchanging row 1 and 3, we can get, let us write row 3 here. 1, 2, minus 5. And row 1 here, 6, 3, minus 4. And row 2 as it is, minus 4, 1, minus 6. The next thing we need, that this minus 4 must be 0 and this 6 must be equal to 0. So we need another row operation to get that this 4 is equal to 0. We shall perform the row operation row 2 plus 4 or 1. We can multiply row 1 with 4 and then we can add with row 2. So this will be 0. To make this 6 as 0, we can perform the operation row 3 minus 6 row 1. Multiplying row 1 with 6 and then subtracting from row 3. So let us perform these operations. 1, 2, minus 5. Now multiplying 4 with 1. So 4 minus 4 is 0. 4 2s are 8. 8 plus 1, 9. And now 4 5s are minus 20. So we get minus 26 here. Now let us multiply row 1 with 6 and then subtract it from row 3. So we get 0 here. Minus 9 and plus 26. Now the next thing which we need is that this 9 must be equal to 1. So by the row operation, we can get just divide row 2 by 9 and we can get 1, 2 minus 5. Let us divide this row 2 by 9, 0. This is now 1 and this one is minus 26 by 9 and this row should be as it is 0 minus 9, 26. The next thing is that we need that this minus 9 should be 0. So let us perform another operation and we can write the operation always on the right hand side. So R2 R3 plus 9 R2. Multiply row 2 with 9 and then add with row 3. So we will get 1, 2 minus 5, 0, 1 minus 26 by 9 and this is now 0 and you can see this is 0 and again you will see that this point is also 0. So this is an echelon form of matrix A. Now in the second part we have to obtain the reduced echelon form. So the column in which 1 lies, all other entries of that column must be 0. This 2 must be equal to 0. So we need another row operation. We can write the operation here on the right hand side that R1 minus 2 R2. Multiply row 2 with 2 and then subtract from row 1. So we can get 1, 0 here. If we multiply this with minus 26 into 2 divided by 9, we get 52 divided by 9. And if we simplify, we can get 7 by 9 here. And write this as it is 0, 1 minus 26 by 9 and the remaining as it is 0, 0, 0. Now the third one is rank of matrix A. So rank of matrix A is equal to the number of non-zero rows when a matrix A is reduced to echelon form. So this one is the echelon form and we can see that there are 2 non-zero rows. So rank of A is equal to 2. Inverse of a matrix. A square matrix B is said to be inverse of another square matrix A if AB is equal to BA is equal to identity matrix. Let us see an example. We have a matrix A, 1, 0, 3, 2, 4, 1, 1, 3, 0. Now we have another matrix B, minus 1, 3, minus 4. 1 over 3 minus 1, 5 by 3. 2 by 3 minus 1, 4 by 3. Now if we multiply A with B and simplify this, we will get 1 0 0 0 1 0 0 0 1. So this is an identity matrix I3, 3 cross 3 matrix. In a similar procedure, if we obtain BA and simplify this, we will get 1 0 0 0 1 0 0 0 1, which is again I3. So we can see that AB is equal to BA is equal to identity matrix. This implies that B is an inverse matrix of A. In this example, we should learn how to obtain the inverse of matrix A by using the row operations. The procedure is that we should write matrix A on one side and the identity matrix on another side. Now we should reduce matrix A to the identity matrix. So for this purpose, we need that this 2 must be equal to 0 and this 1 must be equal to 0. So we perform the operation R2 minus 2R1 and R3 minus R1. And we get 1, 0, 3, 0, 4, minus 5, 0, 3, minus 3. Now we should perform the same operation on I. So we get 1, 0, 0, minus 2, 1, 0, minus 1, 0, 1. In the next step, we need that this 4 should be equal to 1. So we need another row operation. The row operation is by R2 minus R3. We get 1, 0, 3, 0, 1, minus 2, and 0, 3, minus 3. So we should perform the same operation on I. So we get 1, 0, 0, minus 1, 1, minus 1, minus 1, 0, 1. In the next step, we need that this 3 must be equal to 0. So we can write A here and identity matrix on this side. And now we can perform the row operation by R3 minus 3 R2. So we get 1, 0, 3, 0, 1, minus 2. And now this becomes 0, 0, and here we can get plus 3. And at the same time, we perform the operation and we get 1, 0, 0, minus 1, 1, minus 1, 2, minus 3, 4. Now, in the next step, we need that this 3 should be equal to 1. So let us divide row 3 by 3, and we can get by row 3 divided by 3. So we get 1 0 3 0 1 minus 2 0 0 1. Now we have to perform the same operation on the other side. So we get 1 0 0 minus 1 1 minus 1, and now let us divide this by 3. So we get 2 by 3 minus 3 by 3 is 1, 4 by 3. Now in this step we need that this minus 2 should be 0 and this 3 should be 0. So let us perform another operation. So by using R1 minus 3 R3 and R2 plus 2 R3, we get that this is 1 0 0 0 1 0 0 0 1. Now we should perform the same operation on this side. So we get minus 1 3 minus 4 1 by 3 minus 1 5 by 3 2 by 3 1 4 by 3. And now we can see that A has been reduced to an identity matrix, and at the same time we get another matrix on the right hand side, and that matrix is A inverse. So A inverse is minus 1 3 minus 4 1 by 3 minus 1 5 by 3 2 by 3 1 4 by 3. So this is the required solution. That's all.